But typically, and what you'll see in the book, what's calculated is what's called the midpoint formula. So the midpoint formula is to say, if I start out with one point on the demand curve, and I wind up at another point on the demand curve, what am I saying the elasticity of the demand curve is based on only those 2 points? And that's sort of the examples that you'll see. Examples you see in the book will tend to be consumer A the market started here where consumers were paying this price and buying this quantity. And then we moved to a different point where there was a different price and a different quantity. What is the elasticity of the demand curve? Remember here, we just want a number. 1, 0.2, 2.3, to tell us something about this curve. That's what we're calculating. So I think it was multiple choice question 5 in the back of chapter 5, posed this situation. Okay. Suppose we have quantity of fish purchased by the Lee household is 22 kilos per year when the price is $10.50 per kilo, and 18 kilos when the price is $19. Right, so we've got 2 situations, 2 different points on the demand curve. And the question was, okay, what's the price elasticity of demand here, given you've got these 2 points? And you calculate that using this thing called the midpoint formula. Okay, so we could draw the 2 points. So there's point 1, where the price was $19.50 and the quantity purchased was 18. And there's point 2, where price was $10.50 and the quantity purchased was 22. Okay, the demand curve goes through those 2 points, you assume, but we don't really know anything else. We only have these 2 points. And what we're going to do is we're going to calculate what's called using the midpoint formula, sort of a rough guess about what sort of curve we're looking at. Is it elastic? Is it inelastic? So the first thing we do is we calculate what's called the midpoint. So the midpoint is just the midpoint between these 2. So the midpoint between $19.50 and $10.50 is $15. So the midpoint on the price axis is 15. The midpoint on the horizontal or quantity axis is the midpoint between 18 and 22. It's just the average, right? It's 20. And the book makes this out to be really complicated, but it's not necessarily. So what we're then going to do is we're going to calculate the percentage change in quantity divided by the percentage change in price. I think it's easier just to separate it out and just say, okay, well, what's the percentage change in quantity? Well, the quantity starts out at, we'll say 0.1 with a quantity of 18. And we move to 0.2 with a quantity of 22. So the change in here is 4 or minus 4, whichever one would want to call first point and second point. Right? And you divide the change of 4 by the average. And here, remember, the average was the average between 18 and 22, the midpoint. Right? So 20. So you divide 4 by 20, which gives you 0.2. Translate that into percentage. So multiply by 100. So that's 20%. So it's saying that, look, the price rose or fell, whichever way you want to think about it. How much did quantity respond by? Well, quantity responded by 4. What percentage of quantity was that response? Well, the average quantity was 20. So 4 over 20 is 20%. That's it. That's what we've calculated. We've calculated that the response, the change in quantity here was 20%, 4 over 20. What about the percentage change in price? So likewise, we're thinking here, price is going from $10.50 to $19.50 or $19.50 down to $10.50, depending which way you want to look at this. In that case, the average was 15, so it's $9. So the change in quantity was $9. The change in price was $9. The average price was 15. So 9 over 15 is 0.6 times 100 to get it back in percentage terms, so 60%. So look, it's saying that price changed by 60% and quantity changed by 20%. So the elasticity is just the average of those two, the ratio of those two. 20% over 60% is a third, or 0.33. In this case, it's negative because it's a demand curve. So prices go up and quantities go down along demand curves. That's what the law of demand says. So the change in price and the change in quantity opposite in sign, so we get a negative number. In the book, you throw that negative number out, and we just arrive at a positive number. It's just a convention. So here what we got that the elasticity of demand here is a third. Remember? So it's the change in quantity was 20%. The change in price was 60%. So the change in quantity is 1/3 the change in price. The ratio of these two percentage changes. So the Lee's family's demand for fish has a price elasticity of demand of 0.33 or negative 0.33, whichever way you want to present it. And what does it mean? Well, it's negative. Let's just expressing the law of demand. The prices and quantities go in opposite directions. Now, in this case, as the book does, we'll just drop the negative sign and just express it as 1/3, 0.33, just for shorthand. Because why? Well, we always assume that demand curves are downward sloping. And as long as the demand curve is downward sloping, then its price elasticity has to be negative. So as soon as you say demand curve, you already know that it has to be a negative price elasticity. If it had a positive price elasticity, what you'd be saying is, for this good, if I raise prices, people want more. The law of demand, in a sense, rules that out. And economists have looked for goods like that, and we don't really have any reliable cases where we can say someone jacked the price up and people wanted more. So we drop the negative sign and we just express it as a number. In this case, 0.33 or 1/3. What would be the price elasticity of supply? Well, the supply curve is upward sloping. So prices go up and quantities go up. So in that case, prices and quantities move in the same direction. Or prices go down and quantities go down. They both be negative. Either way, the elasticity of supply will be positive as well. But again, because of the law of supply, we just assume that anyway. So we won't be looking at it. Okay, what else is important about 1/3? Well, it's less than 1, and I'll show you later why that matters and why 1/3 becomes important. Prices fell by 60%, but quantity only rose by 20%. So the response of quantity was 1/3 the response of price. Or another way of thinking about it is prices changed a lot, 60%, but quantity changed hardly any.